page 129, 18B.
Yeah.
We've done A, but we haven't done B. Okay.
I'm assuming it's going to be the same procedure. Get a square around each circle, and then deduct that portion.
That's all I was thinking.
Darn thing. Oh, quit it. The least bit of. Now these circles are all the same size.
Yeah.
Let's see. Now, how does it go? I gotta
So I think I came up with 1.17, just
oh. I don't look. But it's better than if I were to draw it freehand, I guess. This is the area you want,
Yeah.
and you know,
We know a radius.
and these are all the same size. This is 1 inch. Okay, so what did you do?
I boxed out one circle and got the area of the supposed square around that circle, giving us the shaded area around the supposed square. Now you get a quarter of that, and you get a quarter of that shaded section here,
Okay,
and times it by 4.
you can do that. Here's another way you could do it. I'll show you another way. If you
Ah,
take that square, which is 1 inch on the side, right? And then take one circle out. Because this right here is a quarter of a circle. So there's 1, 2, 3, 4 quarters of that. So it's one circle out. Does that make sense? That's the way you do it. Is you can.
yeah, you're just going at it from a different approach. We're going to get to the same result, same theory.
If I do the area of the square minus the area of the circle.
Right.
See, and I can just do one circle because it's 4 parts.
Right.
4 quarters. That makes sense?
Yeah.
It's a little bit easier to. So that's then each side is 2. That's a 1 inch diameter. So this is 2 by 2, right?
Right.
So this is 2 squared minus pi r squared. So it's 4. Should come up with the same thing.
Yes, it
You have
does.
4 minus pi. Because
That's what I
r
got, 0.86. Well, rounded.
yeah,
Huge decimal.
yeah.
Yeah, that way is easier.
Yeah.
I cover 2 steps in my procedure.
But I'm not saying what if you any way is correct if you get the right answer.
Right.
if you see this one, it's a little easier to do. Okay. 20. Says the circles in the figure have radiuses 6, 4, 4, and 2. So let me see.
0.4, right? Oh no,
What?
never mind. Don't mind me, it looks like a period's a comma. I better get some glasses.
Now these two are supposed to be the same sizes. I don't know if I can do it. So like here out and from there out. Oh, this one is 6, and theoretically this is supposed to be 4, 4, and 2. And it says, which is larger, shaded area inside the large circle or the shaded area outside the large circle? Well, anyone have? No, this is the reasoning that I would use. Those small circles, whether they're inside or outside, you know, whether they take part of the big circle or none of the big circle. You know, the areas, you know, it's going to, the areas of the sum of the little circles and what's left in the big circle are going to be the same. If you take them all the way out, and then you start, if you put one in, then you take all of that out, you know. So then it'd be the, you understand what I'm saying? Okay. If I were to, that particular thing, and if you did something like this, for example, for one, we had the one I just drew, the area in the big circle should equal the area outside. Now, if you move any of those circles into the other circle, it'll subtract out the same amount from both parts. You understand what I'm
They're
saying?
both losing the same amount.
Yeah, yeah. Right. So all you basically have to say is, does the area, what's the relationship between the area here and the area
The other three,
here? Are they the same or are they different? What?
It's the same.
You said you bet it's the same?
Yeah, it's like the area of like the three smallest.
Yeah,
So
that's what you're gonna find out,
yeah.
but you could prove it. But you understand, the thinking is, this is my thinking, is it, you know, if you take the second way where I did green and red, if you show those areas, how they relate to each other, then you can take any of those circles, move them in or out of the red area, and you're going to lose the same amount. From
Reduction on
both-
one side will be a reduction on the other.
Yeah. It would, whatever you lose on the red circle, you would lose from the sum of the greens. That makes sense? So all we're gonna do is show that what we have to do is show that the areas of the red equal the sum of the areas of the green. That makes sense? So the area green, this is area red. So red is just pi times 6 squared, right? And then the green is, it's pi times 4 squared, but that's 2 times that, right? Dang it. Times 2, because there's 2 of those, right?
2 4s, a 1 and a 6.
Right? Plus pi times 2 squared. Correct? So we have common pi here. And we got 4 squared times 2 plus 2 squared. So 16 times 2, this is 32 plus 4 pi. And that's
Just prove that they're equal.
36. And that's equal to 36. So now if you move any of those greens in or out, it'll take away from that
Both
area.
sides.
Yeah.
Interesting.
That makes sense?
Mm-hmm. Now it does.
Okay. Okay. Concentric circles have the same center. 2 concentric circles have radii 10 and 14. So if we so this is 10, this is 14. And, you know, it's centimeters, but it doesn't, as long as the units are the same, it's going to be okay then. Which is larger, the area inside the smaller circle, the area between the 2 circles? So the area is, let's say, small, right? Area small, and the area between. So the area for the small is pi times 10 squared. And the area between is pi times 14 squared minus pi times 10 squared, right?
Mm-hmm.
So this is 100, 5 times 100. This is pi 14 squared minus 10 squared. And what's 14 squared?
196. Think. Could be wrong.
Yeah, I'll take your word for it. So this is 5 times 96. So it's the area inside the small, right?
Mm-hmm.
Is greater than the area between. Now then, the B part. What would be the radius of the larger circle have to be in order for the area of the inner circle equal the area between the two circles? So the B part. So
Whatever the square root of 100 and 200 is.
what would the radius of the larger circle have to be in order for the inner circle to equal? Okay, so what you do is you go area 10 squared to equal area, and it would say, it says the radius, so it's the radius of the large squared minus 10 squared, right? So pi's go out, you divide both sides by pi, and then you have the radius squared of the large minus 10 squared equals 10 squared. So r squared, that's equal 2 times, well, if I add both 10 squared to both sides, it's 2 10 squared. So then the principal square root of r squared. And we're going to do the plus because it don't make any sense to do minus, right? So principal square root over here, 2 times 10 squared. So r equals 10 square root of 2. So that would be the radius of the large, would have to be that.
And you'd accept that answer, you don't want to
Yeah, that's actually more accurate than if you put it in your calculator. That'd be a rounded answer.
Okay.
I mean, if either way. But if I were doing a problem and plugging a number into another one, I'd use this number because it's no rounding error.
Right, right. So that's what I came up with initially, square root of 200.
Yeah. You know, a lot of times you're interested in rounding errors. You don't want to, if you're using something to solve something else, if you round something off, put it into another thing, and round that up, then what it is, it just keeps, your rounding error multiplies. And you get significantly off. Yeah, I guess I've worked with problems where, boy, you could, you know, if you round off and then round off, you know, plug in, round off, plug in, and round off, all of a sudden you get so far off with your answer. 24. Base and height of a parallelogram are both multiplied by 3. What is the area of the resulting parallelogram? So, yeah. So my height would be the perpendicular distance so if this is the base and then this is the height, so then if you multiply both of those by 3, there's the area of the resulting. So you go, the area is 3 times h, 3 times h, 3 squared h squared, right? base. Yeah, I don't know what I'm doing here. 3 times the base. Base times height. So then if you multiply it by 7, then it's going to be just 7 base, 7 height, 7 squared base height. That would be that next one. What happens if the base is multiplied by m and the height by n? So then that one is, it's m times the base. Doesn't make any difference. N times the height. It's m times n times base times the height. I guess the significant thing is this part is what they're driving at. .26. So they say review example 310. Use the method of that example to verify theorem 3.5 by answering the following questions about the trapezoid. Hate when the arrow goes wrong way. And they're making that thing that. Oh, heck. And they, oh, my line isn't quite, we'll just pretend like that line is there. Attaches to there. And you're saying this thing's right. And we call this H. Call this one base 1. E. Okay. It says in triangle ABCD, base 1 and base 2, oh, here's base 2 here, are the lengths of the bases and H is the height. What is the area of the triangle? So A is the triangle, A, B, D. Well, it's 1/2 A, B, D. So it's that base 1 times the height, right? What is the height of B, C, D? So this is, I don't know, let's call it, this is H, and if those are parallel lines, then this H and this H and this H are the same, right? What is the area of BCD? Is 1/2 of base 2 times the height. And then C, express the area of the trapezoid in terms of the areas of ABC and BCD. So trapezoid A, B, C, D is the sum. Triangle area ABD plus triangle BCD, which is 1/2. It's 1 height, 1/2 base, 2 height, and you factor out the common factors, 1/2 and H, and you have B1 plus B2. Simplify your answer, I already did, by factoring common factors. So this is D. Consider your answer in D. How can you find the area of a trapezoid? So that theorem, we've just essentially proved that theorem. Okay. 30. 28 is a measuring thing. So we'll do that. Here it says the dimensions and costs of 3 different pine gazebos are given. The floors are regular octagons. Which gazebo costs the least per square inch? So the area is equal to 1/2, isn't it? The perimeter times it's the distance from the center to perpendicular to one of the sides. I can't remember what the name of that is. Okay. I don't even know how they list out that formula. I guess they just call it H. Oh. Well, it's a good thing I straight edges. So they're just saying this distance right here is B, and this distance here is A. So in general, the area is 1/2 8 times whatever A is times B over 2, isn't it? See, go from the center.
Professor, why B over 2? Not just a straight height.
Well, see, P is this,
Mhm.
8 times the A. And then this is H, but H, they're gonna give you B. So H is equal to,
Oh, I see,
B over
I
2.
see, I see, I see.
I'm just writing it out so you can put the values that they give you.
I assumed
In.
height was the full thing, height is only to the center point.
It's only to the
My
center.
mistake.
Yeah. So then what you can do, it says the floors of the regular. And then the floors of the regular, which gazebo costs the least per square foot? The least per square foot. So this will give you square feet. So then the cost, I'm just trying to do per square foot. Is going to be the cost divided by the area, right? Which is going to be whatever the cost, they're going to give, so they're going to give you cost A and B. And so what I'm trying to do is just kind of put a general formula together. So this would be 1/4 of 8A times B. So actually, this, when I reduce it down, it's going to be C is equal to 2AB. Right? I'm just trying to do a literal equation, so then I just put in the minimum amount of values and I can get the answer. Then if you were, what you do is then if you were trying to do cost estimates on gazebos, you could just write a Excel thing
Mm-hmm.
and put your values in, just spit it, and then you could just, you know, if they said, you know, the sides are A, B, and the cost is C, you know, then you could just put it in. And, I mean, I'm real big on using Excel and then using literal equations and putting different cells having different values, then you fill the cell in. And I really like to use Excel. So this is like the average cost. That's what they're asking for. So this is the formula for cost. Oh, I wrote it right up here. Per foot squared. So then for that first one, gazebo number 1. And then what we would do is we would put 41. Maybe what I want to do is do it horizontally. Gazebo 1. So it's going to equal 4195 over 2 times 36 and 7/16. Oh man, is this per foot? Square inch. Good job. Those are inches, and then 88. And gazebo 2 will be 5195 over 2 times 57 3/8 times 138 and 5/8. So, have you got any figures?
I left my calculator at home.
Oh. Anybody got figures on that thing? See, in this thing, once I do that, I lose my, I can't split my screen. So I can look at both of them at once. I can't. Be nice if I could, but I won't.
Kids showed me a way. May not have a touch screen. If it's a touch screen, you, on top of the very page, you hold it and drag it, and it'll pop. It'll be half.
Yeah.
Showed me that just like a week ago. Wow. Technology, isn't it great?
I don't know whether.
I don't know.
See, it won't show both of them at the same time. And if
Hold on a
I've
second.
tried to do
No,
this.
doesn't work.
No,
Doesn't work.
that's not a touch in there. But sometimes what you can do, I've done it this way. This one. I think if I maximize that. I don't know where my calculator screen went to. Anyway, do you have the figures? What?
I have the figures. So for the first one, it was 151. Well, 1.51, I should say, 1.51.
Okay.
And then for the second one, it was 1.41. And then the third one was 0.87. I mean 89. 0.89.
So now what's better, larger or smaller?
The least. I guess that didn't agree with what I had got. The only thing is I'm not. I mean, I got for the first one, I got this. For the second one here, I got 33. And then the third one, it's saying, no, I don't, whatever the figures you come up with, it says which gazebo costs the least per square foot. So if it's yours, it'd be gazebo 3, right? If it was, my numbers are right, this is supposed to be a 30. That's supposed to be a 34. And that would be 2. But you see it, whoever figures are right.
I don't have my calculator, I just tried it on my phone.
Yeah.
I don't need the headache right now. I'm thinking happy thoughts and I'll worry about it on Monday.
Okay. 32 says a circular table has a diameter of 48 inch. The table can be enlarged by inserting 2 rectangular leaves, each 18 wide and 48 long. What is the area of the extended table? So, dang it, I can't, I'll have to draw the table up and down, because I don't have the ability to go crosswise. So if you notice that what this is these two make one circle, right? Two halves of a circle, and it's 48 inches. Diameter, and then each one of these leaves, this is 18 inches, 18 inches. So it's actually going to be the area of the circle and plus 2 times the area of the rectangle. The rectangle, which is 48 by 18. Now the area of the circle is going to be pi times r squared, and then it's 2 times base times height. So this is pi 48. The radius is going to be 24, right? Plus 2 times 48 times 18. And that's what, so I didn't put down what number I'm looking at. 32. Okay, did you come up with 35, 37.56?
35, 38.3 I got.
Okay. Anyone even come close to what I got? Okay, yeah, it's okay. .34, it says in the past, a goalie at the National Hockey League could play the puck from anywhere behind the goal line. Beginning in 2005-06 season, the goalie could play the puck only within the trapezoidal area behind the goal. What is the area of the trapezoid? Notice your two bases are going to be 18 and 28, right? And your height is going to be 11 feet. It says, because it says 11 out on the side, or up on top there. I mean, it's kind of roughly what that thing is the goal line is here, and then what they're drawn is this thing that comes around. And they got and it's an isosceles trapezoid. Then they tell you that this distance is 18 and that this distance is 28, and then they say that this right here is 11. So 11 would be your height, and then the area is equal to 1/2 base 1 plus base 2 times the height. 18 plus 28 times 11. I'm just going to take half through there. It's 9 times 9 plus 24 times
28. 9 plus 28, so 24.
No, I took 18 plus 28. You take 1/2 of and multiply it through there, and it's 9 plus 24. That's all I'm doing. Right? Half of 18, half of 28. Oh, 28. I get it. Is 14.
That's more like it.
So then that's 23. 23 times 11. Which is just 23 and 23 like that, right? So it's 253. And it's square something.
Square feet.
Okay. Feet squared. All right. How close are we getting? We're close enough to the end to call it good for this chapter. For
I
this
like your
section.
style.
This section. So next time we'll do 33.
Have a good weekend, stay out of mischief, don't do anything
Have
I
a
wouldn't
safe
do.
trip. I hit it